A couple of years ago, I had a back and forth with a Mr. Thrive and Survive. Now, this is him if you don't remember him or if you've not seen him before.
Yes, his arguments are not scientific. They're ad hominem. He's stupid. What was it? Stupid is a man jar, whatever it is. Must be a British term.
Yeah, it's Marmite, Rich, not man. Can't even get that one right.
Well, it appears that he is still getting eclipses wrong, even after all this time. Dear, oh dear. Hello all and welcome along to another episode of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Right, as I said at the start, the Flat Earther Mr. Thrive and Survive apparently has absolute proof of NASA's lies. This should be interesting.
Okay, let's look at this ridiculousness one last time in the heliocentric model and show unequivocally that this is 100% impossible in their model. Let's take a look at what they show us all the time, and then we're going to take a look at what can be mathematically proven to make this impossible. So when we look at the lunar eclipse, and all you have to do is Google it, and you're going to see, say, a lunar eclipse diagram. And what you'll end up with is different diagrams, but they pretty much look like this.
Now, Mr. Thrive and Survive has a real problem with eclipses and has been a subject of several videos of mine through the years, all of which exposes his unreal misunderstandings when it comes to solar and lunar eclipses.
And the fallacy of this happens to be that they are showing a sun which is huge, but not to scale. I'd say they're showing it about 2.5 times the size of the Earth here. And they're showing it extremely close. In fact, the moon is just barely closer than the sun.
Now, of course, for the purposes of a diagram, it would be absolutely impossible to show what happens to scale because of the vastness of the solar system. Because of the size of the paper, the sun would be a tiny dot, and the Earth and Moon you wouldn't even be able to see. It's specifically done this way to highlight the celestial physics going on when we talk about eclipses.
In any case, let's look at the fallacy of this and dismiss this for the last time. If the Flat Earth community were to come out with a diagram like this to show something with the Flat Earth, there would literally be dozens of comments below stating you're not showing it to scale. It's a trick you're using because if you do it to scale, you'll see it turns out right. And there would be videos by the professor and Marianne and Simon Dan and others who will never try things themselves to see if they're actually right or wrong.
Ah, yes, indeed, we probably would be calling you up on stuff like that. The reason being, though, is that we don't need to do this on our own to find out if we're right or wrong. It's an established fact, Mr. Thrive and Survive. The science has been done countless times by multiple space agencies and institutions. But of course, the beauty of all of that is that you actually can do it yourself if you really want to. Next month, I'll be figuring out the size of the sun using a shoebox, for example.
Well, let's get into it and take a look. And look at this. That's what I want you to notice first. And wait till you see the angles that they use. They use the satanic angles even in their stupid diagrams. So they're showing what I have here as the yellow lines, and that is the sun rays coming from the top of the sun. Why this is wavy and the others are straight, I have no idea. And by the way, if you search science, you'll find out that the photons, whether you think they travel in a wave or not, they will travel in a straight line in space. They don't disperse because there's nothing to disperse. There's no medium. So whatever angle they come out of the sun, they just go forever until they're interrupted or until at some distance there is no more energy left. Now,
so what exactly is your problem then, Thrive? The sun's rays radiate out in all directions, so essentially each ray is emitted at a certain angle. By the time they reach our Earth, because of the huge distance they've travelled, the angular difference between two rays is incredibly small. So for all intents and purposes, they are considered to be parallel. I don't understand why this is an issue for him. Obviously, the lines are only drawn on the diagram like that to show the path of the sun's light in the areas that matter during eclipse. Now, obviously, the sun's light radiates everywhere else as well.
We have the moon during a lunar eclipse is its normal grayish white self. When it gets into the penumbra, which is this grayer area here, is when it actually either turns black or very close to black. And when the moon gets right to about there, that line, that's when you first start to see a little teeny sliver start to turn darker on the moon. And it usually is pretty dark, close to black.
That is not true. When the moon is in the penumbra, it is still being illuminated by the sun, just not all of the sun. The Earth's shadow doesn't appear on the moon's surface until the moon enters the umbra part, which is that small dark area in the middle.
And as the moon moves into this, and by the way, in their model, this is pretty accurate, because by the time the moon moves around, they have to have all these angles, and the umbra has to be this thick for it to work, because this is a process that takes quite a bit of time, relatively speaking. Most lunar eclipses are about 6 hours or so in totality, from start to finish. Now, so to produce the umbra, which is this right here, is these wavy lines hitting the outside of the Earth, and of course they go down then, and it causes a red moon. We're not going to get into the stupid reason why they say it's red, but it's a stupid reason.
All of a sudden, Mr. Thrive and Survive doesn't care about refraction of light. What would you say to a kid if he asks you, why is the sunset red? Oh, don't worry, it's a stupid reason.
And then, but what causes this penumbra? Well, the penumbra is caused, we got the first two lines, right? The penumbra is caused by these other lines, which here you're going to see is somewhere between 20 and 25 degrees. And we're going to look at the angle of these two. You're not going to believe it. So this is the way that goes. From the top of the sun, it crisscrosses in front of the Earth, and that causes this penumbra. The others, which don't crisscross, but they happen to strike at the Earth at this angle, cause this umbra, and then it comes out in the penumbra on the other side.
You're worrying way too much about those lines, Thrive and Survive. This diagram here goes a little bit of a way in showing how it really looks without those lines. Look at the shadows being cast by the different celestial bodies.
Now, I'm going to, let me see if I can do this, just a moment. Now what I've done is I have expanded the screen to the right so you can see the angles as I click on these lines right here. Now these lines, what they are, let me find something here so I can show you. I started out from parallel. So I took a line and I dropped it on like this, top of the sun, and I just moved it out parallel. And I did the same thing at the bottom. So that's about parallel there. And then I applied over here what degree angle, and you ready for this? Watch. I'm going to apply this to it. Minus 6.6 degrees. Watch what happens to that top line. Oh, it matches.
But these images aren't to scale, Mr. Thrive and Survive. All of this is just arbitrary. And surely he knows that those two yellow lines on the images are just two single rays. Rays come out of the sun at all different angles, as we've already discussed. They just use those two lines to simulate the blocking of the sun's light by the Earth.
And this bottom line right here is also, as you can see over here, minus 6.6 degrees, 66.
Which of course will be different on different images of the illustration of these eclipses.
Even in their satanic, well, we know it's satanic now, even in their diagrams they have to use the satanic numbers. And it's not done here.
Oh, the mind boggles. I simply cannot wait.
Wait till we get to these right here. That's interesting also. And again, I did the same thing with these bluish type of lines here, these aqua colored lines. I started them out parallel at the top of the sun, parallel at the bottom of the sun, and then I just applied an angle over here. So let's see what angle got me to match their diagram.
Okay, pause the video right here and lock your guess in the comments, people.
Let's click on this one here. 23.4 degrees. Does that sound familiar? Take 90 and subtract 23.4, because 90 is parallel. You get 66.6.
Oh my days, you don't? What on earth?
And the top one, of course, it matches. Minus 23.4, 66.6 degrees. How about that? Isn't that interesting? Now, one other thing I want to point out before we move on here, and I'll put a box here just so you can see it more easily. If angle A, which is where they crisscross, must equal angle C when it comes out the other side.
Well, at least he knows that.
So it's 23.5 degrees going in and 23.5 degrees going out. I hope that makes sense. So here's graph paper. And what I did was I did everything to scale the way they say it is. And every one little block one here is equal to 1 million miles. So let's zoom in and see what I did with the starting point. I have the front of the sun just touching this line right here. So that's the 0 mile mark.
Where is he going with this?
And then each box represents 5 million miles. So you have 0, 5 million, 10 million, 15. It's not, I didn't do every five. You can figure it out. 20 million. All the way out until we get to 93 million. And by the way, to scale, you wouldn't even see this little line right here at all.
I think at that scale, you wouldn't see the Earth or Moon at all.
Where the thickened line is, because I just wanted to point out where 93 million miles was located, and where this line crosses represents where the Earth is. If you put the actual diameter of the Earth on here, I would have to magnify this probably 5 or 6 more times before we'd even see a little speck.
Okay, so he's happy that the scale is small. Brilliant.
So keep that in mind. And because the line is so thin, it's actually positioned in the middle, but when I made it thin enough, as thin as I can make it and still show, it shrunk it down from the top down. So it's just a little off of dead center from where the sun is located, dead center. Now keep in mind also that a quarter of a million miles is where the moon is. So it would be only 1/4 of the box back from where the Earth intersects this line. So
Great, thanks. I think we get it. Can we move on to your point, please?
very, 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 very close in this scale. So let's back this out. Now let's look at the ridiculousness of all of this. So I started with one line, this purple line here. You can see it starts at the center of the sun, and it proceeds to go to the center of the Earth, right there. And like I said, this line, the violet line here, the purple line, it's thicker. So imagine if the Earth line was thicker, it would be dead on, you know what, accurate. Now let's take a look. Let me click on this line, and over to the right, you can see there's the angle, 0 degrees.
Please do not tell me he's going to do what I think he's going to do.
Which means this is how many degrees off of parallel. Now, if you do a Google search, 9 out of 10 results, if you say, what angle do sunlight rays strike the Earth? They will say 90 degrees. If you get one that's very detailed, they will give you even more. And if you do the mathematics and you find a site that actually gives you the mathematics, it's about 0.14 degrees off of parallel. So 89.86 degrees.
As we discussed earlier.
Is what the sunlight strikes the Earth at from that distance. And you can use the Pythagorean theorem to figure that out yourself. You know, the one part of the triangle is 93 million miles away. And then you can figure the height of the sun, which is 800. Oh, yeah, let me show you the sun. It takes up 80% of the box, as close as I can get it to 80% of the box, because it's 800-some thousand miles in diameter.
865,000 to be precise.
So this is actually to scale. Now let's see how ridiculous their model is. Now I'm going to apply 1 degree. 1 degree off of parallel. And you see it stayed on the sun. It started, because I started the line from the sun, it'll apply that angle And oops.
Yep, he's done it. He's done the absolute classic flat earther move. There isn't just one ray of light coming from the sun. There are billions and billions. Now, taking into account that only 1/1 billionth of the sun's energy output actually strikes the Earth's surface, then we can assume that most of the sun's rays miss the Earth. But of all the rays that are emitted, quite a lot do hit the Earth's surface. And as discussed, because they come from such a long way away, by the time they reach Earth, they can be considered to be parallel. What Thrive and Survive has done here is picked one ray that's emitted from the centre of the sun at an angle of 1 degree. That ray would miss Earth, of course, but equally there could be a ray emitted from north of the equator on the sun that's angled towards Earth, and from countless other areas of the sun that, when you add them all up, blankets the Earth in sunshine. I cannot believe that Mr. Thrive and Survive has done this and considered it a win. I am totally done today. Seriously. Well, there we go. That is all for today. Another Flat Earth Friday done and dusted. I do hope you enjoyed it. Always love looking back at Mr. Thrive and Survive. Maybe he'll do something else on eclipses soon. But for now, if you did enjoy it, then please do consider subscribing to the channel. If you really enjoyed it, then hit that like button as well. I've been Simon Dan. Have yourselves a great weekend, and I'll see you on Tuesday, where we're going back to look at Standing for Truth. See you then.